Hello everyone. In previous lecture we had started Thevenin's theorem. We had seen the statement of Thevenin's theorem and we solved the numeric problems on it. In today's lecture we will practice more examples on Thevenin's theorem. Before going to see example, we will revise the statement of Thevenin's theorem and what is the actual network for Thevenin's. So, Thevenin's theorem, it states that any linear circuit containing one or more voltage or current sources and or resistances can be replaced by an equivalent series circuit having a single voltage source VTH in series with a single resistance RTH connected across the load, where VTH is the open circuit voltage and RTH is the open circuit resistance when all the voltage and current sources replaced by their internal resistances. Thevenin's सर्किट काय आहे किंवा Thevenin's theorem काय आहे, तर कोणतंही कॉम्प्लिकेटेड नेटवर्क आपण एका सिंगल सेरीज सर्किटने रिप्लेस करू शकतो, ज्यामध्ये असेल VTH म्हणजेच व्होल्टेज सोर्स, Thevenin's व्होल्टेज त्याला आपण म्हणतो, आणि त्याला सेरीजमध्ये कनेक्ट केलेला असेल सेरीज रेजिस्टन्स दॅट इज RTH. तर तो VTH आपण केव्हाचा मेजर करतो, इट इज द ओपन सर्किट व्होल्टेज and RTH is the resistance measured when the sources in the circuit are replaced by its internal resistances. So, this equivalent Thevenin's equivalent circuit we had seen in previous lecture. This is the complicated circuit or complex circuit आणि त्या कॉम्प्लेक्स सर्किटचं कन्व्हर्जन आपण Thevenin's equivalent मध्ये कसं करू शकतो, तर ते अशा पद्धती. We have to see the example. Determine the Thevenin's equivalent circuit for the following network. In this network, we saw the previous example. In previous example, the voltage source used was ideal, means the internal resistance was not there. That's why we had put the internal resistance 0. But in this example, here given internal resistance of source is 1 ohm. Resistor R1, R2 and R3. R1 is 100 ohm, R2 is 50 ohm and R3 is 70 ohm, and here RL is connected. Now we have to find out, first we have to determine here the Thevenin's equivalent circuit. To determine the Thevenin's equivalent circuit, we have to solve the example step by step. Step first is to find VTH, step 2 is to find RTH, and in step 3 we can draw the Thevenin's equivalent circuit. So, step 1 to find VTH. VTH find करण्यासाठी steps काय follow करायचे, तर remove RL. We have to remove this RL and the terminals open. In between these open terminals we have to measure VTH. तर इथं RL रिमूव्ह केल्यानंतर जे दोन टर्मिनल ओपन होत आहेत तिथं आपल्याला VTH मेजर करायचा आहे. सो टू मेजर VTH we have to see this circuit, observe this circuit. We can see the one terminal of R3 is in circuit but other terminal is not, means other terminal is open, and that's why there will be no any current flow through this R3. R3 मधून करंट फ्लो होणार नाही, इथं करंट जो आहे तो 0 असेल. सो इट इज रिडंडंट ब्रांच and so we will measure the VTH here at this point. Now we have to measure the voltage between this and this point. The voltage, this voltage is nothing but the voltage drop across R2. So we can see in this figure, I just rearrange the figure, I just remove here R3 as it was as it is redundant. So, here the voltage drop across R2 is nothing but the VTH. Therefore, we can redraw the circuit here as like this. Here 12 volt 1 ohm internal resistance is there, R1 and R2. According to potential divider rule, we can write the formula for VTH as VTH is equal to, VTH is nothing but the voltage drop across R2. Therefore, VTH is equal to that resistor times supply voltage divided by total series resistance. Now, the total series resistance here will be R in, that is the internal resistance of source, then R1 and R2. So, R2 into V divided by R in plus R1 plus R2. If we put values here, we will solve it and we will get here VTH 3.97 volt. This is the step 1. Now, step 2. Step 2 is to find RTH. To find RTH, remove load RL and replace the all voltage and current sources by its internal resistance. मग या सर्किट मध्ये आपल्याला RL रिमूव्ह करायचा आहे आणि व्होल्टेज सोर्स किंवा करंट सोर्सेस जे असतील ते त्याच्या इंटरनल रेजिस्टन्सने रिप्लेस करायचे. आता याच्यामध्ये आपल्याला इंटरनल रेजिस्टन्स दिलेला आहे. इंटरनल रेजिस्टन्स किती आहे तर 1 ओहम आहे. इन प्रिव्हियस एक्झाम्पल वी connect this or we short circuit this as there was no any internal resistance, but in this example internal resistance is given. So, we have to replace this voltage source by its internal resistance, that is 1 ohm resistor. Hence, we can draw the diagram for the finding RTH like this here. Here we have to measure RTH. This 1 ohm, it is in place of 12 volt voltage source. This is R1, R2 and R3. The circuit will become like this. Now, rearranging circuit, we can see R1 and this internal resistance are in series. So, I had drawn here like this, okay, and this R2 is parallel. Okay, we can see these 2 points are common in between this and this. So, this R1 plus R in are parallel with R2. So, just redraw the diagram here and this R3. Okay. Now, we can write the formula for RTH here as RTH is equal to R in plus R1, as these both are in series, and for these series resistance the R2 is parallel. So, written here parallel R2, and for this whole circuit the R3 is in series. So, plus R3. Okay. We just put the value of R in and R1 and R2, R3 here. We will get here 101 ohm parallel 50 ohm plus 70 ohm is equal to, write the formula for parallel resistances, then calculate and you will get the answer here. RTH is equal to 33.44 ohm plus 70 ohm, means RTH is equal to 103.44 ohm. This is the step 2. Now, step 3, we have to draw the equivalent circuit. To draw equivalent circuit, we just replace the all circuit instead of across the load using only VTH in series with the RTH. VTH we got here 3.97 volt in series with the RTH, that is 103.44 ohm, and here RL. Okay. So, here we get the equivalent Thevenin's circuit. Now, we will see the another example. Here, draw the Thevenin's equivalent circuit for the following network and find out the load current IL, that is current flowing through the load resistor RL. आता आपल्याला इथं काय सांगितलंय, Thevenin's equivalent सर्किट पण ड्रॉ करायचं आहे आणि आपल्याला या ठिकाणी RL मधून फ्लो होणारा करंट फाइंड आउट करायचा आहे. ओके. तर हाउ वी कॅन फाइंड आउट द करंट थ्रू RL? will RL we will see further. To find out the Thevenin's equivalent circuit, step 1 to find VTH, पहिली स्टेप असणार आहे VTH फाइंड करण्याची. How we can calculate VTH here? Remove RL and the terminals open there, measure the VTH in between the open terminals. ओके, तर या ठिकाणी आधीचे जे एक्झाम्पल्स आपण बघितले त्यामध्ये R1, R2, R3 असे 3 रेजिस्टर दिलेले होते, पण या सर्किटमध्ये R1 आणि R2 2 रेजिस्टन्स दिलेले आहेत. मग हा RL रिमूव्ह केल्यानंतर जे ओपन टर्मिनल्स होत आहेत तिथं आपल्याला या ठिकाणी VTH मेजर करायचा आहे. ओके, तर वी कॅन सी द डायग्राम हियर वी हॅव टू मेजर VTH. This VTH is nothing but the voltage across this R2. So we redraw the diagram here like this. The voltage source 20 volt, R1 25, R2 50 ohm, and we have to measure VTH across R2. So according to potential divider rule, we can write the equation for VTH as VTH is equal to that resistor times means R2 into supply voltage V divided by total series resistance R1 plus R2. So we will get here R2 into V divided by R1 plus R2. If we put the values here, 50 ohm into 20 volt divided by 25 ohm plus 50 ohm, we will get VTH here 13.33 volt. Step 2 is to find RTH. Now we have to find RTH. To find RTH, remove RL and replace the voltage source by its internal resistance. In this example, internal resistance is not given, means we have to consider it as 0 ohm. Okay, so we will replace it by short circuiting this terminal, and we will get this and remove this RL and measure the RTH here. So we will get the circuit like this. Okay, we have to measure RTH, we replace it by short circuit, and these two resistors R1 and R2, we just redraw the circuit like this here. These R1 and R2 are in parallel, R1 and R2 in parallel. So for RTH we can write the formula as RTH is equal to R1 parallel R2, means we will get, if we put values here, we will get RTH is equal to 16.66 ohm. Okay, next step is we have to draw the Thevenin's equivalent circuit. So to draw Thevenin's equivalent circuit, we just replace the all circuit by VTH in series with RTH. VTH is 13.33 volt and RTH is 16.66 ohm, and this RL. Now step 4 is we have to find out here IL. In this example, one more thing is need to do here is find out the load current IL, that is current through load resistor RL. या RL मधून फ्लो होणारा करंट आपल्याला या ठिकाणी फाइंड आउट करायचा आहे. सो वी कॅन सी दिस इज अ सेरीज सर्किट. हे एक सेरीज सर्किट आहे, and in series circuit we know that the current flowing the series element is remains same. Okay, we previously discussed that. So here let current I is flowing through this circuit. This I is nothing but IL, as this is series circuit. So I is equal to IL. Just apply Ohm's law to this circuit. IL is equal to काय Ohm's law? V is equal to IR or I is equal to V upon R. So we can write the equation here for IL. IL is equal to VTH. या ठिकाणी V म्हणजे VTH आणि R म्हणजे टोटल रेजिस्टन्स या ठिकाणी येईल RT. RT टोटल रेजिस्टन्स म्हणजे RTH plus RL. So VTH divided by RTH plus RL. Just put the values here and we will get IL is equal to 0.114 ampere, means we can write this in milliampere. IL is equal to 114 milliampere. Okay, so now the exercise here for you, determine in first example you have to determine the Thevenin's equivalent circuit and in second example you have to derive the Thevenin's equivalent circuit, also need to find the load current IL. Okay. So, we will stop here. Thank you. If you have any query, you can message me